Homework busy? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
All right, question 44 asks to review conceptual example 7 as background for this problem. That's found on page 994. It has to deal with PET imaging or positron emission tomography. Very interesting, but it states that an electron and its antiparticle annihilate each other, producing two gamma ray photons. The kinetic energies of the particles are negligible. Determine the magnitude of the momentum of each photon. So in this scenario, we're dealing with energies and particles and reactions. So one thing we think of when you consider is that we have energy conservation. So our initial energy has to equal our final energy. If we don't consider the kinetic energies of the positron and electron, then all we need to consider is the rest energy of each, which, well, rest energy of electron and rest energy of a positron are the same. And we're left with I'll say 2 times the energy of the gamma ray photon. So we can say that's 2 times, because they're the same, just the charges opposite each other. 2 times the rest energy equals 2 times energy of the photon. Our 2's cancel out. And since we know in general when we're dealing with particles, our energy is equivalent to mc squared. So if we wanted to figure out the momentum, again, momentum typically is mass times velocity. We deal with velocities in terms of, at least for our gamma ray, so momentum of our gamma ray is m times c. We don't really know what m is because, again, it's massless, so we replace that with e over c squared times c. So momentum is simply e over c. I'll scratch it out. So, sorry, I should replace with E gamma. So maybe I'll make it a little more obvious and bigger up here. Well, if we know our expression for momentum is the energy of the gamma ray over c. We don't know this term, energy of the gamma ray, but we know that's equivalent to the rest energy of our electron over c. Which for an electron, we do know we can represent that as mc squared. M electron is c squared over c. So that would be equivalent to me times c, which if you look at it in terms of kilograms, because we want our momentum to be in kilogram meters per second. So we have the mass of the electron in kilograms, 9.11 times 10 to the negative 31 kilograms, multiplied by the speed of light. Our units are in the proper units for momentum, and we find that the momentum of these photons to 3 significant figures, because that's what I'm starting with here. That should be 3.00. It's 2.73 times 10 to the negative 22 kilogram meters per second. So there you go. So we use energy conservation to recognize the rest energy of our electrons. This is equivalent to the rest energy of our photons. We got an expression for momentum for our particle, for our gamma ray, recognizing that's equivalent to the mass times c of the electron to find our total and final momentum.